Hello, ladies and gentlemen. It's such a pleasure for me to be presenting here in front of all of you. First of all, let me introduce myself in behalf of my team members. My name is Krisnadi Agustan. I'm a part of the research team which led by Mr. Muhammad, alongside with Mr. Berkah Fajar Tamtomo Kyono, Mr. Muhammad Taufiki Rahman, Mr. Budi Setiana, and Mr. Jamari as our team member. We are all part of Laboratory for Engineering Design and Tribology, Department of Mechanical Engineering, University of Diponegoro, Indonesia. In addition to that, Mr. Budi Setiana is also part of Laboratory for Surface Technology and Tribology, Faculty of Engineering and Technology, University of Twente, Netherlands. In this occasion, I will present to you our research results titled Three-Dimensional Hydrodynamic Lubrication Analysis of the Artificial Slip Effects and Engineered Surface Texturing in the Truss Bearings. Here are the outline of our presentation today. We will start with the introduction, methodology, results, and last but not least is the conclusion. Introduction. Truss bearing is a type of bearing designed to support axial load. It is widely used for many applications in many industries and mainly for rotating machineries. This wide application forced researchers to find a way to improve the performance of truss bearings. And one of the methods to improve the performance of truss bearing is by applying an artificial slip or hydrophobic coating. So the artificial slip conditions generally causes a decrease in friction. So it can be used to make a truss bearing design with low friction. Low friction means a higher performance for truss bearing. In overall, most of the findings from recent studies and research point to the potential for widespread use of hydrophobic materials. And in this research, we will observe this with 4 parameters, which is maximum temperature, maximum hydrodynamic pressure, load carrying capacity, and frictional force with respect to the angular velocity of the truss bearing. And this study aims to compare the effects of slip and no-slip conditions to the tribological performance characteristic of truss bearings. The study is conducted using computational fluid dynamics method using ANSYS software, and we can see here is the bearing solid geometry and nomenclature. The upper geometry is called truss collar or rotor, and the lower geometry is bearing pad or stator. And our fluid will be placed within the gap between the rotor and the stator. In the red box, it's the texture geometry. The surface texture will be applied in our study. And this is the geometry specification for the rotor, stator, and the lubricant. The geometry for the truss bearing used in this research is adapted from the work of Papadopoulos and others. And here is shown the geometry of the fluid or the lubricant. And on the right hand side, it's the discretization process. So the fluid geometry on the left will be discretized to a smaller element, to about 150,000 elements with maximum element sizing 0.2 millimeters using ANSYS ICEM software. And this is the governing equations that will be used on ANSYS fluent simulation for solving our case. We can see the mass conservation equation, the momentum equation, the energy equation. And for the parameter observed, you can see here is the function for the load carrying capacity, and the friction force. Next is the thermophysical properties of our lubricant. In this study, we will use ISO VG46 as our lubricant. And for the viscosity, we will use the value of viscosity as a function of temperature. So when the temperature rises, the viscosity value will be changed. For this relation, we use the Macaulay-Walter relation, and to solve this, we use the piecewise linear function at ANSYS Web. And here is the boundary condition for our fluid geometry. The surface will be the inlet with temperature of 40 degrees Celsius and relative static pressure of 0.1 megapascal. And the outer surface will be the outlet with temperature of 20 degrees Celsius and relative static pressure of 0 megapascal. And here are the results of our study. On the left-hand side, we can see the results of pressure and temperature distribution contour of the no-slip condition, and on the right-hand side, we can see the results of pressure and temperature distribution contour of the slip condition. Presented results is the results of 6,000 rotation per minute angular velocity. We can see on the upper half of the slides the pressure contour of the no-slip condition and the slip condition. We can see the maximum value of the pressure. The slip condition have a higher value of maximum pressure. And on the lower part of the slide, we can see that the slip condition have a lower value of temperature compared to the no-slip condition. And here are the distribution plot for the hydrodynamic pressure and the wall temperature at the 6,000 rotation per minute. Represented by the blue line is the no-slip condition, and represented by the red dotted line is the slip condition. We can see at the hydrodynamic pressure plot the value of the slip condition pressure is higher at every point compared to the no-slip condition. Meanwhile, for the wall temperature plot, you can see the no-slip condition have a lower wall temperature value compared to the no-slip condition. We also have here all the plots of 1,000 to 6,000 rotation per minute with an increment of 1,000 rotation per minute for all the 4 parameters that will be observed. We can also see here all the plot of the different angular velocity from 1,000 to 6,000 rotation per minute for all the 4 parameters. We can see for the slip condition, it has a higher maximum hydrodynamic pressure at every angular velocity, which is translated to higher load carrying capacity at every angular velocity. Meanwhile, for the wall temperature, the slip condition have a slightly lower wall temperature compared to the no-slip condition at every angular velocity, and a lower friction force than the no-slip condition. And the conclusion is, artificial slip conditions generate higher maximum hydrodynamic pressure, which translates to higher overall load carrying capacity. And maximum temperature value of microtexture truss bearing with artificial slip is smaller than the no-slip condition at every point. And number 3, the artificial slip generates lower friction force, even more notable at higher operational speed. And in conclusion, truss bearing with artificial slip shows superior tribological characteristic if compared to the no-slip condition on all 4 parameters. That's all that I can present to you, and thank you for your attention.